the most important part, guys, is to compare the training score with the test score and conclude whether this model is a underfit model or an overfit model. That's a very important term. Whether your model is underfit or whether your model is overfit. What is the biasness in the model? What is the variance of the model? These are very key critical terminologies. So in this case, if we look at the training score and the test score, they are quite good. I can say that 73% is a good score for training, and for testing 77% is also a good score. These models can be improved further to give you 90% accuracies. That's one of the case, but still we can say this is a good model. Now, what would have been the cases where I would have said, no, this is not a good model? In this case, we would say this is not a good model. If our training accuracy is around 50% or less, we would say this is an underfit model. Means this model is like a mere guess. 50% of the time it is good, 50% of the time it is bad. Consider that these blue dots are your actual values. Or let's say for a particular customer coming for a loan, these were different loan amounts for different customers. An underfit model, like what it is doing, see, it is trying to draw this straight line. Means it is not able to fit well to this data. When I say what is a good fit model, a good fit model is where this dotted line or the predicted values are almost within the blue dot range. Okay, that is known as a good fit. But in this case, underfitted model, what it is doing, it is just blindly creating an equation based on which it is predicting some values. Look at the problems. Let's say for this particular point, this was the value, the actual value. But if this is the equation that model has learned, the mathematical equation, then the value which it will predict is this one. And between the actual and the predicted value, there is a huge gap. Similarly, here the actual value was this, but what the model will predict is this value. Okay. So guys, what this dotted straight line is, this is nothing but what the model learned. The equation of the line y equals to m of x plus c. What is it? It is nothing but the equation of a line, right? Let me tell you in a simple way. If we say y equals to x, where m is 1, right? So what I'm explaining you guys, before you can understand these charts on my screen, you need to understand what is this equation, y equals to mx plus c. This equation can be of this form, in which let's say m is 1 and c is 0, y equals to x. If I ask you to plot this equation on a chart, how will that be? If this is your x-axis and this is your y-axis, so for every x, if x is 1, y will be 1. If x is 2, y will be 2. So what that line will be? It will be a straight line like this, a linear line like this. Okay. But if I say y equals to x plus, let's say your intercept value was 2. Okay. So intercept value of plus 2 means if x is 1, y will be what? 3. In this case, if x is 2, y will be, add this 4. So that means this line which you have, actually guys, it will be shifted upwards. It will always start from this intercept position, because every value is getting added by the 2 places further on the linear scale, right? So that's how we need to understand the slope and the intercept. So if my data, in this case, blue dots were sort of non-linear, but what model learned was a linear line, definitely that will not be a good fit. Agree? If my data was non-linear and the equation which model learned was a linear equation, it will never be a good fit. It has to learn something like a non-linear equation, which we will discuss in the non-linear regression. But yeah, here you will see it's a swiggle kind of a line. We will talk about that also later. But ultimately, for this kind of data, my model is not a good fit. It is an underfit. So there are 2 ways of thinking this. One is that data is not good for the model. But the second way is that the model you used is not good for this data, right? So second is what we should be focusing on. because data is what is data. You have this because that's the source of truth. But the model that I am using is not the right model. So instead of using the linear regression equation, I should have used a non-linear regression equation, or maybe a decision tree or some other algorithm which could have fitted well on this data. But let's consider the case of our current data set. Our current data set is a linear data only, guys. Okay. So let's say our dots, the actual values are some things like this. It's going linearly in the upward direction, right? So if I have a line which is going somewhere in between these dots, I will say it's a good fit. But let's say the linear equation that your model learned, it's going somewhere at the top of this, or maybe at the bottom of this. Then we can say that this is a underfit model.
Right.
Even on the linear data, you can have a underfit model because it is not fitting well within the range of the actual values. So this linear line was a good fit, but these two will be underfit. Underfitting has a high biasness in model due to which this happens. But when we talk about a good fit model, it is having a low bias, low variance. But now, when will we say this is a overfit model? So let's say during the training phase, you get 90%, very high accuracy. But testing phase, you get 60%. So there is a huge difference between the two. So the first thing is you will look at the training accuracy and you will say, oh, it's excellent. You will be very happy. But you should not. You should also look at the test accuracy. And the test accuracy is going very much down. Means there is a huge difference of 30% between the two accuracies. Means your model is not doing well on the test data. Okay, it may be doing well on the training data, but not on the test data. Means what is happening is the model is getting overfitted on the training data. Think it like training data, what you are feeding to the model is learning everything from that data by fitting well onto that data. It is like you are remembering for every mathematical question what is answer. Like let's say there is a mathematical question, you just completely remember the solution and you go to the exam that okay, I know the solution, but in the exam they slightly changed few values and now you don't know what to do because you just learned that if this question will be asked and this will be the values, uh, I will be writing this answer, but they slightly changed the mathematical values or the parameters and now you don't know what to do. So you sort of learned very well on the data which was exposed to you, but you didn't generalize. You were not able to generalize your knowledge. Okay, and that's where the problem is. So for example, you knew that okay, 2 plus 2 is 4, and you know okay, 3 plus 3 is equal to 6, but in the exam they gave you 2 plus 3 for example, but now you don't know the answer because what you have learned is 2 plus 2 is this, 3 plus 3 is this, but you never generalized how the addition works. Ideally you should have generalized that the general concept of addition is this, now you give me any value, I will do it. So if you look at the overfitted model, what is happening, it is very well trained on the training data and saying, oh, I know everything, now I'm ready for the exam. But now in the exam, as soon as the things changed, it was not able to generalize, right? So the easiest way of telling whether your model is underfit or overfit is looking at these two scores. As I told you, if both of them are very low, it's underfit model. If training is very high but testing is very low, we will say it's overfit because overfitting always is in regards to the training data. So model is very good on the training phase, but in the testing phase it is bad. That's where the overfitting problem happens. The model is not able to generalize, and that's where the problem is. So now how to solve these? Okay, if the model is underfit, right, then in that case what that means is that either the model you are using is not good, so you can change the model, right? Or there are some things known as hyperparameter tuning. We will talk about that. That is the thing. Or the another thing is you can try to get more data and see how it behaves on some more data rather than just with the initial data set that you had. You will try to retrain the model on some different data and see how it behaves. But what is the problem with overfitting? See, in the overfitting, the problem is model is overfitting on the training data. What that means is if on a given data model was good, as soon as you give it some other training data, model will have completely different output. Even during training, if you give two different training sets to the model, it can happen that model is giving very different results because it is overfitting on the previous training data. In this case, we should look for something known as generalization approach, guys. I will talk about the generalization. What is the generalization approach? And the ridge and lasso algorithms, which we will learn, are the generalization algorithm. Okay. So whenever we have overfitting problem, we will go with something known as generalized linear equation, generalized linear regression, GLM. We will talk about generalized linear models or generalized linear regression models. And for that, we have ridge regression, we have lasso regression, we have elastic net. We will talk about them. So that's where uh, I would like to conclude today's session, guys. Thanks a lot for your time. In the upcoming sessions, we will be talking about more things.